Hi everyone, we are talking about the converse of the Pythagorean theorem today. So just to start, we're going to look at some special right triangles and fill out this chart. I've just filled in already what's been provided, so you can go ahead and do that, and then we'll fill in the rest of it together. Okay, so you can pause if you are not done yet, but we can use the Pythagorean theorem here to solve for our missing pieces, right? So our first one, you might know this special right triangle already. This is a 3, 4, 5 special right triangle, so my hypotenuse will always be 5 here. You might know number 2 as well. This is a 5, 12, 13. So you can use the Pythagorean theorem, 5 squared plus b squared equals 13 squared. Solve for b, and you will get 12. A 3, 7, 24, 25. This is an example of a 7, 24, 25 triangle. And to be honest, this is about what you will see. You don't see these as often, but there is a pattern that I want you all to notice. So we will go on with that. Number 4, this is an 8, 15, 17. Number 5, we have 9, 40, 41. Number 6 is 11, 60, and 61. Okay. And we could actually even move on. There's another one that we can go on to. There's an infinite number of these. So there is a pattern here. I'd like you to see if you can figure out what it is. I'll give you a hint, a slight hint. This one is weird. It doesn't really follow the pattern so nicely. But there is a pattern here. And maybe you do this, you'll see. Yeah, go ahead and try adding these up together. Alright, so if I add these up, first one I get is 9. Next one, 25. Next one, 49. If I add these up, I get 32. That's why this is a weird one. For some reason, I don't end up getting a perfect square. But then I move on to 81. I move on to 121. And actually, there's another one we could talk about. So there's the 13, 84, 85 triangle. That gives us 169. All right, so I do end up getting perfect squares with all of these. This is 3 squared. Whoa. Let's get rid of that. This is 3 squared, 5 squared, 7 squared, 9 squared, 11 squared, 13 squared. Alright, so all of my odds. Alright, so 3, 5, 7, 9, 11, 13, and onwards, all squared. Hey, what's cool is that you can also use these, or any multiple of these. It's really just the relationship or the ratio between the legs. Right? So if I had, for instance, a 6, 8 triangle, then I would know that the hypotenuse is 10, because it's just a 3, 4, 5 triangle dilated by a factor of 2. Right, so that will all work out. We'll go through a few examples of those as well. Alright, so first example, I have a set of numbers. There's a common factor. I want to factor that number out of the set and figure out which set that these numbers relate to. Okay, so first I have 20, 48, and 52. Okay, so all of these share a 4. You can divide by 2, divide by 2 again. So I can take a 4 out of this, and I see that something's happening. Okay, I see that I end up with 5, 12, 13. Alright, few technical difficulties. Okay, next one, I have 7 root 3, 24 root 3, and 25 root 3. This one's a little bit clearer to see. If I just eliminate all the root 3's, I have a 7, 24, 25 triangle. Okay, now they want us to not use the Pythagorean theorem and figure out the missing dimension. Okay, so let's see if we can figure out what group these fall under. I have 14 and 48. So if I divide these by 2, I'll end up with 7, 24. So I know the next one must be 25. I multiplied by 2, so my missing hypotenuse will be 50. Alright, next one. It looks like I have a factor of, it looks like 5 halves. Right, so it looks like this is a factor of 5 halves. So if I divide by 5 halves and multiply by 2/5, I end up with 5. I'll end up with a 3. So I know that the missing number is 4. So 4 times 5 halves is going to be 10. Okay, and next one, 9/4, blank, and then 41 over 4. Well, looks like it's just divided by 4. So my missing number will be 40, but over 4, reduce that to 10. Right? So my missing number will be 10. So, like I said before, there's some triples that don't follow a good pattern. However, a lot of them do. So sometimes it works out. Remember, you can always use the Pythagorean theorem. This is just a time-saving mechanism. If you notice the pattern and you happen to know it, then great. If you don't, you can always use the Pythagorean theorem. That will always work. Okay. So what we're given here is the Pythagorean theorem. So if the triangle is a right triangle, then the sum of the squares of the lengths of the legs is equal to the square of the hypotenuse. So what I want to do is write the converse. So what I'm going to do is take my P to Q and write this as Q to P. So if, and I'm going to take my Q statement, if the sum of the squares of the legs of a triangle equals the square of the hypotenuse, then, and now my P statement, it is a right triangle. Okay, so that is my converse of the Pythagorean theorem. So what's significant about this is, whereas before, right, you knew not to use the Pythagorean theorem unless you had a right triangle. Now, using the converse of the Pythagorean theorem, if I am given the 3 legs of a triangle, 3 sides of a triangle, so the 2 legs and the hypotenuse, I can use those legs to determine if my triangle is indeed right or not. So my first question here is a triangle with side lengths 16, 30, and 34 a right triangle? So I see that this is an 8, 15, 17. So this is my weird one that didn't work out. That was example 4 up above. So this is 8, little technical difficulties here. Okay, 8, 15, 17. What's going on? 8, 15, 17. Okay, so it's just multiple of 2. So what I want to know is if, right now I can tell it's the right triangle, but what I want to know is if 16 squared plus 30 squared equals 34 squared, then my triangle will be a right triangle. Alright, so if this is true, then sure. And this will end up being true, so I know that my triangle is a right triangle. Alright, so this is fine. Okay, what I would like you to do is take a few minutes and try to fill out this table right here. What we're trying to do is figure out if, given the sides of a triangle, I can determine if my triangle is right, obtuse, or acute. Now, right, we just talked about, right? It's the converse of the Pythagorean theorem. But I can actually use the legs, the sides of my triangle to determine if my triangle is obtuse or acute. And that's a rule that I'm trying to figure out right now. So what I would like you to do is fill out this table, see if you can come to a conclusion, okay, and then we'll talk about it here in a few minutes. So go ahead and pause the video and try to fill out the table. Okay, and hopefully the rule that you came up with was, for right triangle, we kind of know, right? So it's going to be c squared equals a squared plus b squared, right? This I know. Now for an obtuse triangle, what we find is if c squared is greater than a squared plus b squared, then my triangle is obtuse, right? And if c squared is less than a squared plus b squared, then my triangle will be acute, right? So meaning all of my angles are less than 90. Okay, so let's use this in a few examples. So now they want me to determine if this can even make a triangle, and then if the triangle is acute, obtuse, or right. So again, I'm finding a squared plus b squared, I'm finding c squared, and then I'm determining from there. Okay, so for my first example, my hypotenuse will be 10, and my legs will be, I guess I could write c, will be 10, and then a and b will be 5 and 7. So if I'm comparing, I will have 100, and then 5 squared plus 7 squared is 74. Okay, 100 is greater than 74, so that means c squared is greater than a squared plus b squared, so this will be an obtuse triangle. Okay, b, clearly 5 and 8 would be a and b, and then 17 would be c. However, I do notice that 5 plus 8 is 13, and 13 is less than 17, so this actually can't even be a triangle. So remember, all the way back from last semester, we talked about this. Right, next, I have 3.8, 4.1, 5.2. So I see that 5.2 would be my C, and then 3.8, 4.1 would be my A and B values. So I am comparing, let's see, 27.04 would be 5.2 squared. And my A squared plus B squared would be 31.25. So A squared plus B squared will actually be larger in this case, making this an acute triangle. Right, next I have 9, 11, 15. So 15 squared is 225. Okay, and I'm comparing this to 81 squared plus 121 squared, so that's going to be 202. My C squared is larger, so this will be obtuse. Okay, next one, 7 root 6, this is around 19, so this is going to be my C value, and 11 and 13 will be my A and B. So if I square everything, what I'm doing is comparing, this is 49 times 6, you could think about it that way. So this will be 294, okay? And then my A squared plus B squared is going to be 290, so very close, but my C squared is larger, so this will again be obtuse. Okay, and then last one, this might be the easiest one. I have root 3, root 4, and root 5. So comparing them, I squared, square root of 5 squared is 5. Square root of 3 plus the square root of 4. Square root of 3 squared plus the square root of 4 squared is just 3 plus 4, so 7. So 7 is larger than 5, meaning this must be an acute triangle. Alright, now last example. They want us to determine if angle 1 here is acute, right, or obtuse. Now this is a little bit confusing in the way that they wrote this, but the side lengths of this triangle are 5, 6, 7, and then the angle measure is named 1. Okay. So we have a 5, 6, 7 triangle. So I'm comparing my hypotenuse, which is 7, to my A and B values, which are 5 and 6. So 7 squared is 49. Comparing those to 25 plus 36, which is going to be 61. So obviously 61 is going to be greater, meaning that this is an acute triangle. Right? This is an acute triangle. So that means that my angle here, so my supplement to 1 must be an acute angle or less than 90. So because these angles are supplementary, that means 1 must be greater than 90. So 1 must be obtuse. And again, that's because 1's supplementary angle, or the angle that adds to make 180 with 1, okay, 1 supplementary angle is an acute angle, is less than 90. So in order to make that happen, in order to be supplementary, 1 must be obtuse. Alright, that is it for these notes. Your homework is below here, so let me know if you have any questions. Otherwise, have a fantastic rest of your day.